I'll introduce myself. My name is Andres Moreno. I'm a principal architect at Caylent, an AWS community builder, and an AWS user group leader. And I'm here to talk to you about how you can skip the middleman when building conversational agents. What does this mean? I'm going to show you how you can build direct, secure UI to agent communication with Amazon Bedrock. I know that's quite a mouthful, so let's go through this so you can understand what I mean. So when I started building conversational agents, what do I mean with a conversational agent? It's not a chatbot, it's an actual agent, but you're communicating with it sort of like ChatGPT, but it has access to do things. And when I started building these, I kind of started following the typical architecture that I was already building for my standard web applications, where I have the browser, then I have an API, where I then have some sort of compute. And then here, instead of calling a database or anything, I'm triggering my AI agent, right? There's multiple layers, and if you want the interaction you get for something like ChatGPT or Claude, I would then have to stream information back from the agent into a Lambda function, into API gateway, and then into the browser so the users can see it. At some point, I even had a tool for the agent that the agent would call to send messages back to the browser whenever it had some updates, right? But I didn't want that. And talking with several people, I saw that they were having the same issue where we had multiple layers to be able to invoke our Lambda function properly. In this case, I was starting to think, why can't I just remove that Lambda function and just call it directly from wherever I'm at? So in doing some research, thankfully, early on, I found that AWS had solved this problem for me. So I could provide direct UI to agent communication, where I could have my browser or my UI application. I can have my agent, and I can communicate directly with it. And in this case is via WebSocket. So you're creating a persistent connection where you can have bidirectional communication between your user and your agent. And in this case, I'm using Agent Core, which is the purpose of this talk. I wish it was this easy and these were the only two components, but one of the questions comes up, it's like, are you just opening this WebSocket connection? Anybody can connect and you can trust everybody to use it responsibly? Well, no. So adding a few components, my full architecture looks something like this, where I have my UI application. Then I have users authenticate against Cognito to retrieve a JSON Web Token, a JWT. Then we use that token to communicate with an API that has a single endpoint in this case. So that API secure, it has authentication. And we make a post connection, which is going to retrieve a pre-signed URL. Who here has heard of pre-signed URLs before? Probably in the context of S3. Yep. So in S3, you basically generate a pre-signed URL that you give your user, your client, your browser, so that you can upload a file directly into S3 without having the file go through any type of compute or anything that you have to manage, right? Simplifying that interaction. In this case, we're doing the exact same thing, but for a WebSocket connection. So we get this WSS:// and a massive URL that we can then use for our browser to connect directly to our agent and Agent Core. So I know my colleagues here asked the same question, so we'll see. Hopefully more hands get raised here. Who here has heard about Agent Core? And those who didn't raise your hand, you didn't read the full title of the talk. Who here has used it? Okay, we got a few hands. So just to level set everybody on what Agent Core is. So Agent Core is a service released by AWS last year. You wouldn't believe it's been only a year, but it's grown so much since they released it. And it's composed of several modules you can use independently. And that's what's cool. I can choose 3 of the modules, only one, and use it wherever I want. So the 3 main ones I end up using a lot are Agent Core Runtime. So this is used to host and run your agent. So this is very similar to a Lambda function. You give it the code, and AWS takes care of running it when it's invoked and scaling it when you get too many requests so that you can keep all the requests active. The second one is agent core memory. This one allows you to give your agent short and long-term memory. Short having a maximum amount of days of 30, which is still pretty long. I can't remember what I had for lunch yesterday. So short is still pretty good, and then long-term. So this is so you can keep context of the conversation or any other things you want your agent to remember. Then we have Agent Core Gateway. This module allows you to expose APIs or other MCP servers, Lambda functions, as an MCP server. MCP meaning Model Context Protocol. So this is the way agents discover and execute your tools. It's very similar to HTTP, right? It's you define your endpoints and you can call them via HTTP. In this case, you're defining your endpoints are your tools, and you're exposing them with MCP. Then there's other ones like observability, which allow you to better monitor your application and find out what's happening. Eval, so you can evaluate models and different prompts. Policy, to secure your agent a little bit more. Identity, to give it access to other AWS services. And many other things that I'm not going to talk about right now because it's not the purpose of the talk, and I would take all day just to talk about all the modules they offer. So I want to show you a little demo that I built. I had built it for here to show it to you, but it's something I actually found myself using these past few weeks. I've been traveling a bit, and I have to pack. I'm a terrible packer, and I'm terrible at identifying what to wear depending on what the weather is and the temperature. So I built this application or this agent called Wearcast, where I ask it about a place and a specific date, and it will tell me what I should wear. So it helps me pack for trips like this one. So on the left side, we have the code. That's a GitHub repository. On the right side, we have the application. If you want to use it, you can create an account. It'll create a user incognito, and you can sign in and run your interactions. So here's a little demo. Hopefully it plays. So here we have Wearcast, and I promised it was secure, so I have to sign in. And then I'm going to trigger a prompt. Here's, what should I wear in Indianapolis today? I did record it last week, so it might not be as accurate as today. But here we can see it thinking. We saw a tool call, and we got a response, right? So it's telling me in Indianapolis, it's 77.2 Fahrenheit. You should wear light clothing, right? In the future, I could probably give it a picture of my closet, and it could choose the clothes for me. So that's a feature request for myself. So that's the agent, right? And you can see we got the stream response. We did a tool call, and we did all the fancy stuff you see with agents. But how does it look? So what does the browser see in this situation? So here I have the dev tools, right? And the network tab, so we can see what's going back and forth from the network. So when I loaded this, it's probably too small, but we have a first endpoint it's the connect, right? So this is the post endpoint, which gives me back my WebSocket URL. So you can see it's a massive URL with the signature. And then we have the WebSocket where we use that. So it connects. I'm going to scroll up to the top, and we can see our request going in. And then we can see all the events coming back from the agent, word by word. Sometimes might be 2 words. You can see some tags that say thinking. That's how we show the little thinking block, and then the tool call and all those nice things. So you can see the whole messages here. That's how we built the UI. We're getting these messages and then parsing them so we can show them. So kind of our demo architecture, getting the connections looks like this, right? So we have our browser and we have our agent core runtime. So let's take a look under the hood. How does the code look? So here's my agent. At the top, this is with Python. You can do it with TypeScript here. This is what I decided to use. Use your preferred language. So we can see at the top we have 2 imports. So I'm importing the agent core runtime SDK and then Strands agents. So Strands agents, it's an agentic framework. which basically abstracts a lot of the complexities of the agentic loop, tool callings, and some other things that I'll talk about in a little bit. So we can see we're creating the Bedrock Agent Core application. This takes care of bootstrapping a bunch of stuff, so we don't have to, right? So there are several endpoints that you have to have in place for it to be able to check the health of the agent and all that. This takes care of bootstrapping that. And then we can see we have a handler. So very similar to a Lambda function, it's the function that's going to get called when your agent is invoked. So similarly like Lambda, you have a handler that gets invoked, and that's what's going to trigger. And then inside the handler is where we're actually creating an instance of our agent. And at this point, we're only giving it a system prompt. And I'll show you how that looks and how I'm telling Workcast what to do. And then we have this for loop. So this is where we're actually invoking our agent. And we're using stream async because we want it to stream the response as it's getting it back. If we use the regular invocation model, you would do the request, and then when it's done, you get the response, and then you send it back. In this case, we're getting every event back, and then we're calling this handle event. So this handle event is just a bunch of ifs checking, hey, is it thinking? Is it the proper message that we should return? Is it doing a tool call? And then if there's actually an event that we identified, then we call the WebSocket send JSON, and that takes care of publishing the message to anybody that's connected. So pretty straightforward. This is slimmed down, so if you open the repository, this is a little bit bigger, but I had to fit it in the slide, so this is what you get. Oh, yeah. So how do you expose it as a WebSocket, right? So you have your agent core runtime, and you want to, this specific one, you don't want to do it via HTTP. You want to do it via WebSocket. So thankfully, the people at AWS made this easy for us, where all we have to do is, where did you go? There you go. Is add this decorator to the function called app.websocket. In the regular invocation model, where the one you probably see on all the documentation is app.entryPoint, that exposes the HTTP. In this case, this will make sure that there's the WebSocket where we can get that connection so that our browser can connect to it. And that's it. Initially, I thought this was going to be something in the infrastructure when I'm defining the agent core runtime in my infrastructure as code and anything like that. But no, it's more within the actual implementation in the code. So as promised, here's the system prompt, right? So if you don't know what you use the system prompt for, it's just to basically give your agent the personality and the guidelines. So here is I'm telling you, you're Workcast, you're friendly, weather-based, clothing, advisor. I gave it some reasoning guidelines and then the response tile. So at the end, you can see I always ask for, in these scenarios, I ask for Markdown as a response so I can easily render it. That's why you saw the highlighted light clothing in bold, because it's returning all this in Markdown. And that's it, right? So we have our agent. We could run with that, but it's not very useful if you're maintaining a conversation and it doesn't remember what you already talked about, right? So we want to give it that context. So how do we add that memory? And here's first a little video showing that agent running without a memory. So I go, same request that I sent, and now I'm going to ask it, what about next week? So in this case, it tries to call the tool. It didn't send the city. It just failed because it didn't remember we already asked about Indianapolis. So without memory, you're basically starting a brand new request from scratch with zero context about what happened each time you ask a question. With memory, it's more of a conversation. It has the context of what happened, so you can get better responses if you have follow-up questions. So how do we add that? Well, not yet. This is how our architecture is growing. So this, to me, still falls within the agent core box, but taking a little bit of a closer look, it's like, okay, I have a runtime and I have the memory, and we're connecting both of those. So how does this look in the code? So I have a function to create session manager. Session manager is something that Strand agents provide. that basically manages all the events for you. So if there's a new message coming in, it adds it to memory. And if it's responding, it takes care of retrieving those memories to use it within the context. So I don't have to do it manually. I consider myself to be very lazy, so whenever someone provides things like these, I'm just going to use them. So you can see in this case, we're providing agent core memory config. So I already created a resource in AWS for my memory, and I'm just providing the identifier for that piece of configuration. And then we have the agent core memory session manager object. So that's what we're going to use. It has all the config. And now going back to our agent instantiation, all we have to do is add that object here, right below the system. Well, it doesn't have to be below, but as a parameter for the agent. So now we're giving it the session manager. And now if we go and run this again with that, we'll do the same exact request. And we're going to ask it, what about next week? And you can see now I get a proper response. It's like, okay, for this date, 6/26, it's not today, but in 2 days, because I recorded this on Friday of last week, this is what you should wear. So now the conversation is more interesting. You get a better response because it has memory. And one thing is an agent without tools is just a chatbot. And I don't know, I can't remember who I was talking to about yesterday, but I did this, right? So it's just a chatbot. And you send a request, and based on the knowledge it currently has, it's what it's going to respond with. But with tools, you're giving it access to the world, or to do an action, or to do a web search, or to do something. So let's go ahead and add tools. I already showed you throughout every of the demos you just saw how it's actually calling a tool. So I'm just going to show you how it looks when you don't have a tool. So here we are. We're going to do the same request. It's thinking, but it didn't call a tool. So you can see its response is based on my current knowledge, or my general knowledge. This is how Indianapolis is between the months of June and July, so you should probably wear this, right? So it's just general knowledge and not targeted, forecasted knowledge with the weather API that we gave it access to. So now I'm going to show you how you can actually add the tool call that we've been using throughout the presentation. So there's two ways. There's a built-in way. So if it's a simple function that you're only going to use for this agent, you can define this inline within your runtime using strands agents. And this is how it looks. I know it's a lot of code, but it's essentially a single function. It takes an input of a city. It figures out the latitude and longitude, and then it goes and calls a weather API and gets you the temperature and whatever information it needs to be able to classify what you should wear. And all we have to do is, if you look at the top, we have that little decorator, add tool. That's the thing that makes it available for your agent to use. But we still need to tell the agent, hey, you have this tool available. So going back to our agent, what do? We add that line. It's tools, and it's an array of tools that you're giving it access to. Strands agents provide several built-in tools for like calculator, and I think there's one for like getting the current time and stuff like that. In this case, we're using one that we built ourselves. But imagine that you start building more agents, and they're all using weather data. You don't want to keep copying and pasting that function into all your agents. So how do you expose it so that more agents can use it? And that's where Agent Core Gateway, wrong button. Agent Core Gateway comes into play. So I can pull this functionality out into a Lambda function and expose it as an MCP server using Agent Core Gateway. And how that changes our code is that we create this MCP client pointing to that Agent Core Gateway. So when you deploy an Agent Core Gateway, it gives you a URL, basically this URL /MCP. And we use that to configure it, and it's a target of Lambda. So here we're specifically telling it this is a Lambda function. And going back to our agent here, what do? We add it as a tool. So I replaced the get weather with the gateway MCP client, and now it has access to that same tool, but it's exposed via MCP and invoking and calling a Lambda function. And you can see with this, once you look at the actual code, it's no more, probably 20, 30 lines more here because of the handle event function. But with this amount of code, you can get a fully functional conversational agent with memory and tool calls. So I think it's pretty incredible what they're doing with this service that is really simplifying. They just released, well, they released it a while ago, but they just made it public or general GA, Agent Core Harness, which is still adding a layer of abstraction further than this, where you just tell it, give it your system prompt, which is essentially what we're giving it here. System prompt, which tools do you want to use, and do you want memory, and they take care of everything. So there's multiple ways we can use this service to be able to achieve our goals and be able to create responsible agents. So that's everything I had for you. I didn't see any presentation with the survey link, so I don't know if it actually works, but try it. Give it 5 stars if it gives you the option. In the middle, you have a link to all my socials, and on the right is the GitHub repository with the whole code. Thank you, everybody. Any questions? Yeah, this is, so that Lambda, so the question is this doing anything different than getting like an HTTP URL or something like that? So this Lambda function is basically taking in the agent core runtime ID and then building up that WebSocket URL and adding your signature. So you provided your JWT, so it's going and with Cognito generating that signature. There's no like specific library, like we have the pre-signed URL library for S3. There's not something for this yet. Hopefully they simplify that. But right now I'm building that because I know the URL that's going to get generated based on the agent core runtime ID, and then you stamp it with the signature. Well, thank you, everybody. I'll be around if you want to ask more questions. So thank you. Yeah!